Hey, I was going through the video on hyperbolic geometry and there's so much unpack. Have you seen the part where they show the Poincare desk?
Yes, the Pointer test is fascinating. It's like an alternative world of geometry inside the circle, right? What struck me was how lines in the test are always perpendicular to the edge of the circle.
Exactly. In this model, line extends from one side of the desk to the another, and they have to stay perpendicular to the edge. But did you notice that there's always the concept of parallel lines here that different from Euclidean geometry?
Yeah, that's what's one of the wildest part. In Euclidean geometry, you can only have one parallel line through a point outside the line, but in hyperbolic geometry, you get an infinite number of parallel lines through that point. Imagine a point outside a line and drawing countless lines that never intersect the original line.
That blew my mind too. It's like every rules we learn about parallel lines gets a twist, and a triangle are all so unique. I remember the video showing how the sum of the angles in the triangle is always less than 100 degrees in hyperbolic geometry.
I know the angle sum is never equal to 100 degrees, and it actually depends on how close the triangle vertices are to the edge of the desk. The closer the angles get the edge, the smaller they become.
Right. It's like the edges of the disc compress the angle. And did you catch the part where they try to make a rectangle in hyperbolic geometry? It's impossible to get four right angles in a quadrilateral there.
That was so counterintuitive. In Euclidean geometry, rectangles are everywhere, but in hyperbolic geometry, the fourth angles cannot stay at 90 degrees. Even if you get three triangles, right triangles, the fourth one won't cooperate. If just show how different the rules are in hyperbolic space.
Definitely, it made me realize how unique hyperbolic geometry is from Euclidean geometry. And the video even mentioned that if the two triangles are similar, they are also congruent. It's it's like there's no concept of similar but different size triangle.
Yeah, that's because distances and scaling work differently in hyperbolic space. It's also new different and makes me think about geometry in a completely different way. This video mentioned an app for experimenting with hyperbolic geometry. Maybe we should try it out to see these properties in action.
Great idea. Let's explore both the pointer rest and the upper half plane model. Seeing these work properties visually should make it easier to understand how hyperbolic really works.